My name is Jarahhi, and I am an associate professor of electrical engineering at UCLA. I'm the director of terahertz electronics lab, and in my group we work on various terahertz devices like sources, detectors, modulators, spectrometers, and also we are exploring different kinds of applications of terahertz waves for imaging, sensing, and spectroscopy. Terahertz is a part of the electromagnetic spectrum that is between microwave and optical frequency ranges. A lot of molecules have very unique spectral signatures at terahertz frequencies, and that allows us to identify different chemicals from remote distances. Also, a lot of optically opaque materials are more transparent to terahertz frequencies, and that allows us to access environments that are visually inaccessible to us. Also, terahertz wave energy is much less than X-rays or even optical waves, and as a result they're non-ionizing, non-destructive, and as a result they can be used for different medical imaging applications. As a result of all these unique specifications, terahertz waves have potential applications for industrial quality control, chemical sensing, biomedical diagnosis, different space applications, and we are very excited about all these potential applications. The focus in my research has been mostly on developing more efficient terahertz optoelectronic device components. So in my group, as a major part of my research, we were working on a specific kind of metallic nanostructures that we embed them in semiconductors. And when we shine them with laser light, we can get a much more efficient generation of terahertz waves and detection of terahertz waves. So, for example, if you use this kind of source and detector in an imaging or spectroscopy system, you can get more than 1,000 times sensitivity. And that was a great motivation for us, so that's an area my group has expanded a lot on that, and now we're using these sensors for many kind of imaging and sensing applications. On another direction, we are working on different kinds of reconfigurable metamaterials to basically build passive device components that are missing at terahertz frequencies. Working in optics or microwave regime, one can take for granted a lot of different filter options, modulator options, switches that you have available, attenuators, but these are not very trivial at terahertz frequencies. So we have worked on various types of metamaterials that we can electrically manipulate its spectral and spatial properties at terahertz frequencies, and we have shown very interesting results in unprecedented waves for changing the direction of terahertz waves, which is very important for remote sensing, or modulating the intensity of terahertz waves over broad bandwidth, which is very important for imaging and sensing. Terahertz has been before used for tomography for detecting cancerous tumors, but because sensors were very large, it was limited to scanners which were operating out of the body. But now we're working on miniaturizing these sources and detectors such that they can fit in endoscopy and bronchoscopy probes, so we are extending the potential application to a different domain to do in vivo imaging inside body. Or in another direction, we are collaborating with JPL from NASA, where we're using our technology to build very high sensitivity spectrometers for detecting spectral signatures of gases in different planetary atmospheres. In another recent work, we are using terahertz waves to basically monitor the dynamics of different biological processes at nanoscale without using any labeling molecule. Whenever a new chemical bond is formed or is basically detached in a biological process, you can see the changes of your terahertz spectrum, and we are utilizing that kind of potential functionality for monitoring biological processes. There are a lot of great applications for terahertz which have been known for a long time, but the scope of their potential use was really limited because of lack of devices. So we think we are in a very good position to go back and re-examine our luck with those applications with better tools that we invented to hopefully not only get better performances from these devices but also identify new applications. One of the things that is still missing in the field that has prevented exponential growth on the consumer market has been identifying a killer application, like what cell phone industry did, what computer industry did. We are really looking for that kind of killer application that can bring a big flow of funding and resources and experts to the field.